Hello everyone, I'm Sanika Bhalbar from Comms A and I'm here with Rishika Banerjee and Parth Champanerkar for IA1 of Information Security. We have chosen the topic SNOT. SNOT is the foremost open source intrusion prevention system, that is IPS. What is SNOT? SNOT is an open source non-penetrative intrusion prevention system that monitors network traffic for malicious activity and takes action based on predefined rules. It was created by Martin Roche in 1998 and is now maintained by Cisco. What SNOT does? It one detects suspicious network activity by analyzing packets. Two logs network traffic for debugging and analyzing. Three, prevents intrusions by blocking harmful packets in real time. How SNOT works. One, it packet captures. SNOT examines network packets as they travel. Two, rule matching. It compares packets against a database of attack signatures. And three, it alerts generation. If a match is found, SNOT notifies administrators or takes action. Its modes of operations are one, sniffer mode, two, packet logger mode, and three, intrusion prevention mode. Why SNOT is important? SNOT helps organizations to detect, analyze, and prevent cyber threats efficiently. Its customizable rules, real-time analysis, and free availability makes it a popular choice for network security. Features of SNOT. First, it is open source and lightweight. SNOT is a free to use and does not require heavy system resources, making it accessible for individuals and organizations. Two, it is signature based detection. SNOT uses predefined attack signatures to identify threats, allowing for a quick and accurate intrusion detection. Three, real time traffic analysis. SNOT inspects packets as they pass through the network, enabling instant threat detection and alerting. There are three modes of operation. One, sniffer mode. SNOT functions as a packet sniffer, similar to TCP dump, allowing users to view network traffic in real time. Two, packet logger mode. Stores network traffic for a later analysis, which is useful for security audits and forensic investigations. Three, intrusion prevention mode. Acts as an IPS, detecting and blocking malicious packets to prevent cyber attacks. How SNOT works. Packet capture. SNOT analyzes networks packets in real time by capturing incoming and outgoing data. Two, rule matching. It compares captured packets against a database of predefined rules to detect suspicious activity. And third is alert generation. If a packet matches a rule, SNOT generates an alert or takes action such as locking the event or blocking traffic. SNOT rules overview. Structure of SNOT rules. SNOT rules follow a structured syntax consisting of an action, protocol, source, destination, and rule options. The following is a given example. This rule generates an alert if a TCP packet is sent to IP 192.168.1.100 on port 80. Example of a basic rule. A simple rule might detect ICMP ping traffic, helping to monitor network activity. SNOT installation and setup. The following are the steps to install SNOT on Linux or Windows. First, download SNOT from the official website or package manager. Second, install necessary dependencies like PCAP and DAQ for packet capturing. Three, configure SNOT with rule sets and network configuration. Four, test the installation by running SNOT in a sniffer mode. Required other dependencies like libraries like lib, PCAP, and DAQ are needed for SNOT to function properly. Configuring SNOT. Advanced technologies in security and defense. Setting up SNOT rules, users can create or modify rule files to define attack patterns and security policies. Two, running SNOT in different modes. SNOT can be executed in sniffer mode, logging mode, or IDPS or IPS mode. Further, we'll show the implementation of SNOT.
Hello, I'm Parth Champanerkar and I'll be showing the demonstration of Snort execution. First, we start by downloading Snort from its official website, and we even download the community rules. We can even customize the community rules to enhance Snort's threat detection capabilities. Here, we even download npcap to ensure that we can capture network traffic on Windows, and C++ redistributable is downloaded so that we ensure that Snort runs properly on the Windows. So things in snort.config, this configuration file contains essential settings for Snort, including network variable definitions, rule paths, and processor settings. The IPvar variable was modified to configure the internal and external network addresses, ensuring accurate traffic monitoring. Here, to set the correct IPvar value, the network configuration was checked. The subnet mask of 255.255.0.0 corresponds to /16 in CIDR notation. This information was used to accurately configure Snort's network setting. The IPvar variable was updated in snort.conf to define the network range. This configuration allows Snort to correctly analyze and filter traffic based on specific IP addresses. Adjusting IPvar is a crucial step in setting up Snort for a specific network environment. Here we can see all the networks interfaces available on the network with command of snort/W. So snort/v, this command captures and displays network packets. Example of detecting a simple attack would be running snort with a rule to detect ICMP requests and can generate alert when someone pings a system. Here, we run the command and we can see it has commenced the packet processing. These are the options in Snort which we can use and could be used accordingly according to your needs. So here, Snort command is running in IDS mode. So the Snort is running for interface 5, which is taking rules from snort.conf, which directs to the rules file, and is logging it into Snort log with alert console. And Snort in packet logging mode with detailed packet analysis. Here we can see that Snort processed 1,732 packets, which is 346 packets per second, out of which 31732 were analyzed, which is 98.76% of packets, and 22 of them were outstanding, which is 1.254%.
Snort gives us the advantage of creating custom Snort rules, and you can write any basic rule. For example, this rule shows that we can alert ICMP, and this rule generates an alert when an ICMP ping is detected, testing and applying rules. After writing a rule, Snort must be restarted to apply the changes. Logging and alerts in Snort. So, evolving threats and emerging technologies. Snort logs detected threats. Logs are stored in directories like as it's mentioned, and they include details about flagged packets. Examples of alert messages. An example log entry might look like as it's showing, and this indicates a high priority alert. Non-penetrative traits of Snort. Snort is defensive and not offensive. So Snort does not launch any attacks. It only monitors and blocks threats. It is a detection and prevention software. Rule-based detection. So unlike penetration testing tools that actively probe for weaknesses, Snort relies on predefined rules to identify threats. And passive mode availability. Snort can operate in a passive mode where it only detects threats without blocking traffic. And there is no direct exploitation, unlike penetration testing tools, for example, Metasploit. Snort does not attempt to exploit security vulnerabilities. Advantages and limitations of Snort. Users can create custom rules to fit specific security needs. Real-time intrusion prevention, basically it detects and blocks malicious traffic immediately, and it works with other security tools. It can be integrated with firewalls and SIEM systems for enhanced protection. And also, it can generate false positives, may mistakenly flag legitimate traffic as malicious, and it needs frequent rules update. It must be updated regularly to recognize new threats. Performance impact on high traffic networks can slow down traffic if not optimized properly. Importance of Snort in cybersecurity. It's critical for threat detection. It helps identify and mitigate cyber threats in real time. It enhances the network security and provides an extra layer of protection. And it supports compliance. It helps organizations meet security standards. and it is used in security operation centers, and security analysts use Snort to monitor networks and respond to attacks. The future of Snort and intrusion prevention. It'll be used in AI and machine learning integration, because future versions of Snort may use AI to automatically detect. They also will include cloud-based deployment, because it is increasingly being deployed in cloud environments for scalable security solutions. There is advanced automation, where automating rule updates and threat response will improve efficiency and accuracy, and growing importance in security and information of things and 5G networks. As IoT and 5G expand, Snort will play a crucial role in protecting these infrastructures. And to summarize the entire presentation, in today's demonstration, we showcase the practical implementation of Snort, which is an open source intrusion detection and prevention system. And the following operationals were tested. We tested sniffer mode, which showed that it captures and displays live network traffic. We showed the packet logger mode, which stored network traffic for analysis. There was intrusion detection mode, which detected suspicious activities based on predefined rules, and custom rule implementation, where we showed how it was created to detect ICMP traffic, and the intrusion prevention mode, where configured Snort in inline mode, and we detected and blocked, and we explored the security features. And the demonstration effectively highlighted Snort's role in networking security through sniffer logging, IDS, and IPS capabilities. And the key takeaways included custom rule creation, alert tuning, and real-time prevention of threats. Thank you.